Our DIY slot car electronics gets a nice casing. It took ages for the design, but now it's finally here. We had so many new ideas that I had to expand the ESP32 based hardware several times. The functions are quite comprehensive, and the thing has actually become much more than just a simple lap counter. It was definitely worth it, and you know, we are publishing everything you need to replicate it by yourself. If you were following the previous episodes, then you can understand all of this. The development of the electronic hardware is completed, and we are now designing a suitable housing for it. The Arduino code runs stable, so that all the features mentioned here are running reliably. In the next step, when the lap counter is wired to the racetrack, things are getting really interesting. I'm so excited to see how the lap counter performs in a tough slot car racing scenario. We will definitely make some videos showing that. And I think we will develop more software features, because we wouldn't be Electronics Unmasked if we didn't have a lot of new ideas. I can tell you in advance, we will improve the setup so that you can change the Wi-Fi credentials and some parameters more conveniently. Maybe we will implement a Bluetooth connection. Probably we will add new functions to analyze a race. And it just comes to my mind, I have to explain in a separate episode how to record a race on a PC. So, if you don't want to miss anything, it's best to subscribe to the channel immediately. Now let's finally talk about the casing. Our design incorporates ideas that we discussed based on our own sketches, cat designs and apparently beer bottles. Oops, the bottles weren't supposed to be in the video, but I swear there was no alcohol in them. We really liked the Dunlop bridge design, because it is a classic, but we derived our own design inspired from it. In reality, the Dunlop bridge is a pedestrian bridge that you can find at many racetracks around the world. We decided to install the complete electronics in a single housing. I mean, there is pros and cons for that, and of course you could do it differently. What do you think about that? Write me in the comments. We designed the housing relatively big for several reasons. On the one hand, the electronics should not overheat, and on the other hand, the infrared sensors should be shaded against disturbing light from above and from the side. If you would like to know more about this, I recommend the episode about infrared sensors on Electronics Unmasked. The sensors should be mechanically adjustable, because you might want to use the lap counter for different model racing tracks. Of course, we have to route the cabling to the racetrack to the outside somehow. For this we need holes in the casing of adequate size. By the way, there will be a separate video later on the entire cabling of our model racetrack. We need to assemble the case from parts no larger than 220 mm, so that we can print it on an affordable 3D printer. I can tell you, we put a lot of effort into some of the details. For example, take a look at the solution for the optimum positioning of the sensors. I also think the 3D letters and the panels for the F1 start lights are really cool. Of course, it was teamwork. My two nephews always support me very well in these things. In case you need support with your 3D prints, then I have a tip for you. It is PCBWay, the sponsor of this video. Besides PCBs, the company offers 3D printing and a lot more as a service. Just take a look at PCBWay's websites. It really is the easy way. With just a few clicks you upload your data and you get an offer that you can order immediately. And this is what it looks like with the electronics installed. We have the two infrared sensors here. On the right we have the main board with the ESP32 development board, which has an USB port and a Wi-Fi adapter. The LEDs for the F1 start lights are on this board. And this is the relay board to control the power supply of the tracks. On the left we have a row of luster terminals that we are using to connect the wiring. The cables are fixed with cable tie. I'm using a recycled USB data cable to connect the electronics to the power supply. This can be a simple USB charger, a power bank or a PC. We will talk about the data connection in a later video when it comes to data recording. We designed the case so that we could test it on the racetrack before closing the casing. And this is important because we want to adjust the sensitivity and the optimum position of the infrared sensors. And this is what the lap counter looks like on the birthday presents table. However, the recipient still has to attach the visors for the F1 start lights himself. In the end, we didn't have enough time for that. But I think he is very happy about it anyway. It was quite an effort from the initial idea to this casing design. There was a lot of input and we all had a lot of fun with the project. But you know, it's always nice when you eventually made it. I wish you many exciting races using our lap counter. By the way, it could well be that we will develop a version 2.0 with some improvements and a more compact design. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.